In this video, I'm going to do a demonstration of the COGO coordinate transformation routine in Trimble Access. We use this routine to translate and rotate coordinates that are in usually an assumed system of 5,000 north, 5,000 east, and we're going to translate these coordinates onto monumentation, corners, or control that we find in the field by GPS, and those are on state plane. So we want to get the local coordinates onto state plane. That's the whole point of this video. So I have a project, a translate rotate example project. Let's open that. And I have a job started with some files linked. Let's take a look. So usually when you get your project set up, you have your deed plotted as a background DXF map, and you can go ahead and get started. You'll have search corners on these as well, and you can start looking for them and doing the work in state plane. You may also have some parcel data from a GIS website. And here we have also a TIFF image as an aerial photograph. In this case, we're going to pretend we don't have that information. So I'm going to turn all of that off. Let's say we just don't have these here. But we do have some search corners, and they're in a local coordinate system. So let's go with that for the example. So if I zoom out to the extents, we have some monuments here, and we have search corners. Let's look at the point manager. So here's the state plane coordinate values on those monuments that we found up by the road, and these are search corners in the local assumed coordinate system. Our objective is to get these onto state plane using the coordinate transformation routine, translate, rotate. So let me show you a little bit more about that. If you're interested to know just where these are, I have this open in Google Earth. Let's take a look. So here's our project in Google Earth. These are the two monuments we found up by the road. And we have the search corners in the 900 series. If I click on one of those, it's going to fly down to that location. And we see that that point 901 is way down there in the ocean, off the coast of, where are we here? North Carolina. All right, so we're going to translate and rotate these coordinates up to, get them up out of the ocean, back up to where we are working. You can see here I've also included a little information on the Massachusetts state plane coordinate system. The mainland is here. I'm showing you the origin and the central meridian, that green line there, and the two parallels, a northern parallel and a southern parallel. Massachusetts is a Lambert conical projection, and I have examples like this for Long Island and New Jersey, New York, and Pennsylvania. So let's take a look again. Here's where we are working. And in the example, you're going to see how we're going to take point 901 and translate it to point 201. And after that, we're going to perform a rotation to get all of the coordinates where they belong. So I'll close Google Earth. All right, we're back to Trimble Access again. And just to recap what's happening, we have two concrete monuments that we found, 201, 202, and we have search corners in the 5000 series, as we saw when we looked at them in the Point Manager. So we're going to do this in two steps. We're going to translate these search corners to the project location. That'll be the first step, using translate. And the second step will be using rotation or rotate to get them into the proper location on the project site. All right, let's get started. We'll begin with going to COGO, Adjust, Transformations, and we're going to select Translate first. I would tell you and suggest that you not attempt doing both of these at the same time. It's a lot easier to do the translation first, to get these near to and where they belong, and then solve for the rotation as a second step. So with Translate selected, we're going to click Next, and we're using the 2-point method. The deltas, you would have to know what the difference is. You could calculate that, but that's not as quick as this method here, where I already know which of the search corners I've located in the field, and I'm just going to tell it my search corner 901 needs to go to my found monument 201. And when I do that, it calculates for me the difference in northing and easting and elevation as well. And you can see, that calculation has been made. So we now know the amount of translation needed. And I'll click Next. And what we need to know now is which points do you want to apply the transformation to. So we're going to select the points. And to do that, we'll click the Add button. And you can see there's there's a wide variety of choices that you could make on how to select the points. The one I'm going to suggest you use every time is by name range or point range. So we want to select 901 through 906. Also mention here that let's say you had a lot of search corners, maybe like up to 952 or 924, and you just don't remember how many there were. I could literally say 999 here, and when I click Next or Enter and Add, it's only going to grab the series, the points in the 900 series from 901 up to your last search corner. So here we have the points selected, and we're going to click Accept. And the first thing you're asked is, do you want to apply this transformation? Just to be sure that's really what you intend to do. And when I click Yes, watch what happens to these points. Keep your eye on that. So I'm going to say Yes, and it tells me that it transformed 6 points. And watch here, I say OK, and now we see they're gone. Where are they? Well, they're up here. They've been moved up there by translation, and if I zoom extents, we could see here that the coordinate, that these search corners are now near my project location, but they are not on it. Let's back out a little bit. You remember from looking at it in Google Earth and the TIFF image I was showing you before, these two monuments are along the road and the project is really here. So we're now ready to do step 2, which is to solve for the rotation needed to get these coordinates where they belong onto the project site. 901 is now on top of 201. 902 needs to be on top of 202. And likewise, we'll select all these points and the rotation will be applied to all of them. So let's do that next. Step 2 is applying the rotation, adjust, transformations. We can uncheck translate. We're going to select rotate, click next, and the first thing you need to know with the rotate dialog is which point is the origin point, or in other words, what point do you want to rotate around? And it's going to be 901 or 201, either one. And the reason I say that is those two coordinates are identical. Let's take a little pause here. If we do an inverse between 201 and 901, you'll see that the distance is 0, and the reason for that is that we took that 5,000 value of 0.901 and translated it to the state plane coordinate of 201. So now their coordinates are identical. So just to make that point. Okay, back to rotate. So I'm going to rotate around 201. And if I knew what the amount of rotation was, I could key it in. But I don't know what it is. So we're going to solve for it using, just click this little triangle. We're going to use the to azimuth method. And what you're being asked for here is the azimuth in the assumed system and the azimuth that you want to rotate that to is azimuth to, and that would be the state plane azimuth between 201 and 202. So let's input the local assumed azimuth between 901 and 902. So there's the assumed azimuth, and the azimuth on state plane between the monuments we found is 901, I'm sorry, at 201 to 202. And now we know the amount of rotation needed to go from here to here. So, okay, so we have it all input now. We know what we're going to rotate around, and we know what the amount of rotation is. So we'll click Next. The next thing we need to know is which points do we want to apply that rotation to. So we just go back to Add like we did before, select Points by Name Range, and we're going to use 901. And again, if I didn't know how many were there, I could type 999 and it would select them all in the 900 range. This time I'm just going to put 901 to 906, Add. You can see here they're all selected, and I'll accept that. Again, you're asked, do you want to apply that defined transformation? I'll say yes, and you could see that happened very quickly. They all rotated down, and you're told that the results were that 6 points were transformed, and now they're down on the project site. Let's pan a little bit up this way, and there we have it. Now we have coordinates that we could use to navigate to. We can go into stakeout, create a stakeout list, and start looking for these points. Let's look at them in Point Manager. And where they used to be in the 5000 series, they're now in state plane coordinates. And I'm not going to say that you can use these to set the corners. Let's not get confused here and thinking you're going to navigate your way to this point at 903 using stakeout and then set a corner here. No, that's not what this is about. This is for recon only, and it means that you could find your way to these locations and look to see if anything's there. And you might find an iron pipe here. You might find a concrete monument at 905. You might search diligently at 906, and you may find nothing at all, in which case you should stake out that and locate that location. Store it as search corner not found, so that you can bring this information back to the office, and in the office they're going to see what you found at 904, at 905, and that you looked diligently at 906, and we have a record of that. You just locate that spot to the nearest tenth, let's say, and just indicate nothing was found there. That's good information to have. And so that completes the Translate Rotate in Trimble Access. The next thing I'll show you is a little animation I made in PowerPoint just to look at this another way, or look at it visually, as to what's happening. So let's go take a look at that. So just to emphasize what we just did, these are the monuments we found that are on state plane. These are the search corners on the local system, way, way, way far south. So we're going to calculate the distance and direction to get 901 to 201, and we're going to apply that to the entire group to translate them. And once they're translated, the next thing we have to do is calculate the amount of rotation required. So we have an azimuth between 901 and 902. That's azimuth 1. And we have an azimuth on state plane between 201 and 202. And with that, we can calculate the amount of rotation needed. Okay. And we're going to apply that to all the points. And when we do that, we now have all of those search corners are on state plane. And so that's the end of this video. More coming. Stay tuned. Have a good one. Bye-bye.